Hi, in this video we're going to take a look at the January 2013 Higher Paper 2 question 25, and as you can see it's got a fairly complicated diagram in it and a picture. The pictures are relevant, which is not really important to actually answering the question. You won't get any information out of it. It's just a random illustration that they've put in order to make the paper look more interesting. Now, problems like this with diagrams, especially at the end of the paper when we're up at these high numbers, tend to use either the sine rule or the cosine rule. Now, in actual fact, this one is the sine rule, and we'll see that as we progress through it. But at the start of the question, you don't actually have enough information to use either the sine rule, or for that matter, if it's a question using the cosine rule, very often you don't have all the information up front, and you've got to generate information. And the main way to generate information is by working out angles. Now, the very first angle we can work out is up in the corner here. It's a right angle triangle. We've got 59 degrees here. We know that's 90 here in the corner. So it's a simple matter of subtracting them away from 180 to find out that that angle is actually 31. Now, the next angle that we can find out is next to it, because, as you know, two angles in a straight line must add up to 180. So again, it's another simple subtraction to get that number as 149. And lo and behold, we now have two angles within this triangle here. So again, we've got another 180, subtracting away two angles that are inside the triangle to find out that that's 21 degrees up there. Now, that's work that's just using simple angle rules, and that is actually picking up marks in this question, even though you haven't actually started to use the rule or whatever rule it is you're needing to use to solve the problem. So you're getting marks just by putting the angles into the question. Now, we're left with this triangle up here where we have three angles and we've got one of the sides. Now, as soon as you've got more than one angle in a triangle and you've got a side, then it is the sine rule that you're going to be using. Okay, so two angles or more and a side means it's a sine rule. So we're using the sine rule in this case, and it'd be useful if we could find out this line here. We're trying to find the overall height of the flagpole. We're given this bit at the top and we need to find this bit down here, dB. Now, in order to do that, we need to have this line here. We need to have this hypotenuse worked out so that we can use simple trig at the end to work this out, as you'll see in a moment. But in order to do that, we need to find out what this hypotenuse is here. Now, it's actually the side that's opposite that angle there, the 21 degrees. And we're going to call that side A. And we'll call this side C, where we have 16.5 meters. Now, just running through what you would then do with that. The sine rule, of course, is A over sine A equals B over sine B equals C over sine C. Now, that is on your formula sheet at the start of the paper, so you would just refer to that in order to pull it out. Now, anytime you're using this, you're only going to be using two of these. You're not going to be using all three. So we're using A over sine 21, or A over sine A is equal to B over sine B, and we've put the values in there. The 10 degrees that's down here, and the side that's opposite is the 16.5 meters. Now, it's irrelevant whether it's called B or C or whatever. The main thing is you've got two ratios. The ratio of this side divided by that angle is equal to the ratio of that side divided by that angle there. We just rearrange the equation, bring the sine 21 over so it multiplies the 16.5. Notice that I'm doing this a step at a time in the calculator. I'm working out sine 21, writing it down. This is the way it should appear on your paper in order to avoid calculator errors and losing marks. All the way through here, I'm possibly picking up marks, so it's important to show every step. And then I do sine 10 and write that down in here. And then finally, I multiply these two numbers together to get that, divide them to get an answer of 33.95. So we know that the length of this hypotenuse is 33.95. We're now left with a right angle triangle with an angle and a side, and we want to find this side here. Now, this is the opposite side, and we've got the hypotenuse, so it means we're going to use sine. Sine of 59 is equal to the opposite, BD, divided by the hypotenuse, which is 33.95 in this case. Rearrange this, bring the 33.95 over so it multiplies the sine 59. Again, do the sine 59 in the calculator and write down your number, and then do your multiplication, and we find that the answer is 29.1. So this distance here is 29.1. Add it onto the 16.5, and we get the overall height of the tower as being 45.5. Now, notice that you're asked for three significant figures. Do not put 45.5634 or whatever happens to appear on your calculator, you must make sure your answer conforms with what they've asked for in the question. So always double check that at the end of the question. Okay, that's all for this video. Thank you for listening.